Hi everyone, I hope you are doing well. I know that these are tough times, so I'm trying to find a way in which I can explain the problems in the best possible way to you. So far, my initial thought has been to just upload the answers, but I know that most of you are going to have hard times to understand the solutions. So I have decided to solve 2 or 3 problems from each tutorial and send you a video recording through YouTube, I guess. And this is going to be it. Basically, for the rest of the semester, I'm going to upload the answers and I'm going to solve 2 or 3 problems on my iPad so that you understand the problems better. Also, you can find the questions on LMS. I'll try to provide a link on the description, link to the description. And if you have ideas on how we can improve this so that I can explain it in a better way to you, just send me an email so that I can improve my videos. Also, I need to mention that it's a bit hard for me to write on the iPad, so I might make some mistakes in calculations. I don't want to go back and forth of editing with the video. I'm going to make it as natural as possible, so just ignore the mistakes and please bear with me. Okay, so we will try and solve questions 1 and 4 from tutorial 4 today, and here we go. Let's try and solve problem 1. As you know, as I told you already, you can find the questions either on LMS or you can download them from the link in the description. A summary of the question would be that we have a salesperson and that person lives in Bloomington. Also, I know that he must be in Indiana on Thursday. And we are trying to determine on Monday, Tuesday, and Wednesday where he should go next. Basically, we have some possibilities for these cities. We have Indiana, Bloomington, and Chicago as his possibilities. From the question, we are told that the profit or the earnings the salesman earns for that particular day by spending a day in Indiana are $12, $16 for Bloomington, and $17 for Chicago. Also, we are given the cost of traveling from one city to another city. As an example, the cost of traveling from Bloomington to Chicago is $2, respectively $2 from Chicago to Bloomington too. In this question, we are trying to determine the path in which we should take. So this is a network problem, and the question is asking us to maximize the profit. Now, to have a better understanding of the question, I have created a diagram in which we see the network in which we can take. For example, if we are in Bloomington, we can either go to Indiana, stay in Bloomington, or go to Chicago. Similarly, say for example, if I am in Indiana, I can stay in Indiana, and for that the cost of traveling will be 0 because I'm staying in the same city. I can go to Bloomington, and the cost of traveling of going to Bloomington would be $5 and $2 for going to Chicago. Also, I know that I can earn $12 by spending a day in Indiana. Having said this, let's try and solve the problem. When we're trying to solve dynamic problems, it's always important to determine the following. We need to determine our stage. We need to determine our state and our decision. What is a stage? A stage is the measurement in which you can separate the problem so that you can solve it in an easy way. For example, you can take days in this problem. Say here, I want to separate the problem into days, then I can say Monday, Tuesday, Wednesday, Monday, Tuesday, sorry, we can go back. We have Sunday, Monday, Tuesday, Wednesday, and Thursday. So in this problem, our stages are days. Days, and we can call it a D. A decision is what you're trying to determine in the question. For example, in here, we are trying to determine where to go next. So our decision is where to go next. Let's call this XT. And what is a state? The state is the information you need to know in order to make a decision. In this case, what do we need to know? In this case, we need to know our current location. Let's say I want to make a decision. I want to make a decision. Say I want to go to Indiana, Bloomington, or Chicago. But in order to make that decision, I need to know where currently I am residing in. So in this case, Bloomington. Now I know that I'm in Bloomington and I have these possibilities. So it's important to know our current location. So our state is current location. Let's call this an I. Last but not least, it is also important to determine our objective function. So FT is our stage, IT is our state, and we are trying to maximize the problem. What are we trying to maximize? We're trying to maximize our decision. Okay, having said all of this, now we can start solving our problem. The first stage, let's, instead of names, let's give it numbers. So we can call it 1, 2, 3, 4, 5. Always in dynamic programming, we are trying to solve the problems backwards. So we start from stage 4. Now, stage 4. F4. What is our state? Say we are in Indiana. If I am in Indiana that day, do I have a possibility? I forgot to add some lines here. Yeah. Do I have a possibility? Yes, I have only one possibility. If I am in the last day, on Wednesday in Indiana, I have only one possibility, and that is to go or stay in Indiana in this case. And I earned $12 by spending a day in Indiana. Since I am staying in the same city, the cost of traveling from is going to be 0 because I'm staying in the same city. So our total is $12. I have another possibility. If I am in Bloomington that day, do I have any other choice where to go next? No, I have only one possibility, and that is Indiana. So I earn $16 by spending a day in Bloomington, and I am going from Bloomington to Indiana. How much is the cost of traveling from Bloomington to Indiana? That is $5. So Bloomington to Indiana is $5. 11 minus 5, 16 minus 5 is 11. And I have Chicago as my possibility. By spending a day in Chicago, I earn $17. And the cost of traveling from Chicago to Indiana is $2. Let's double check that. Chicago to Indiana is $2. $15. Okay, now we are done with stage number 4. Sorry. So now is we are in stage 4, so we move to stage 3 now. Again, I'm not used to this program yet, so bear with me. Stage 3, computations. Now, again, let's suppose I am in Indiana, here. In this case, I have various possibilities because I can go from Indiana to Indiana, or stay in Indiana, go from Indiana to Bloomington, and to Chicago. Hence, I have to choose the maximum between them. So, F3 of Indiana, maximum. I'm spending a day in Indiana. That's I'm earning $12. Since I'm going to Indiana, I have cost of 0. I can go to Bloomington from Indiana, and if I go to Bloomington, then the cost of traveling from Indiana to Bloomington is $5. And I can go to Chicago, and that is $2. Make sure, yes. So we have 7 and 10. But I have another possibility, not plus the next stage is profit. So I'm going to Indiana in here. Let's do it like this. Indiana, Bloomington, Chicago. So I go to the next stage, F4I, F4B, F4C. Now I have $12 I earned that day. F4I equals to $12. So 12 plus 12 is 24. Then I have F4B, so it's 7. F4B is 11. 7 plus 11 is 18. And I have 10. F4C is 15. So 10 plus 15 is 25. Which one is the maximum? We select the maximum, which is this one. Now, if I am in Indiana, I say go to Chicago next. I have another possibility following the same logic. F3 Bloomington, have a maximum. So I, B, C. By spending a day in Bloomington, I earn $16. And the cost of traveling from Bloomington to Indiana is Bloomington to Indiana is $5, 507. So we have 507. This is 16 minus 5 is 11. 16 minus 0, 16, and 9. Also, I need to consider where I'm going next. F4I, F4B, F4C. F4I is 12, so 11 plus 12, 23. 16. F4B is 11, so 27, and F4C is 15, so 24. Choose the maximum again. If I am in Bloomington, we say stay in Bloomington. So X3B say in Bloomington. Again, following the same logic, we do the same here. Okay, now since we skipped that part in the fast forward, the logic remains the same. Now we go to stage number 2, and in stage number 2, we have the same process basically, so I am just going to fast forward it again. You just need to follow the same exact steps. Okay then, now we have reached the first step or the first day of the problem. We have stage 1. Now it is our first decision to make. So let me show you in the map here. Now we are in here, so we have only one possibility, and that is I am in Bloomington and I will go to either Indiana, Bloomington, or Chicago. So in this scenario, I am here. By spending a day in Bloomington, I earn $16. So and if I decide to go to Indiana, then I go to F2I. If I go to Bloomington, I go to F2B, or if I go to Chicago, go to F2C. So this is 11. F2I is 40, so that's 51. This is 16. F2B is 43, so that's 16. 69, and we have 9. F2C is 49, so 58. Hence, we say in the first day, sorry about that, in the first day we say stay in Bloomington. So, first decision, we are in Bloomington. We say first decision, go to Bloomington. So we track that. We are at F2B now. F2B, then in this case is here, F2B. We are going to, again, we are staying in Bloomington. So we're going to F2. So we're staying in Bloomington. F2B says go to Bloomington. So we are F3B. Again, we are staying in Bloomington. Here we are in Bloomington. We have a maximum of Bloomington. So again, our last decision is, Bloomington and then Indiana. This is the answer of the first question. To recap it, we tried to solve it backwards and we found that we should stay in the first 3 days, Monday, Tuesday, and Wednesday in Bloomington, and then go to Indiana. I hope I didn't make any mistake. If I made a mistake, you understand the logic, but the mistake might have been a calculation mistake. Let's go to question number 4. And in this question, we have a person who has $4 million available. We know that this person can only invest 0, 1, 2, 3, or $4 million for the sake of the simplicity of the problem. And we are given a table in which we see the amount of return if you invest a particular amount of dollars. For example, if I invest $3 million in site 1, then I will get $9 million in return. I'll get 12 if I invested in site number 2. I'll get 13 if I invested in site number 3. And the idea of this problem is simple. We are trying to determine in which site how much money to invest so that we maximize our revenue. Now, we always, when solving dynamic problems, we always need to determine our stage, state, and decision. Our stage, as we said earlier, is the way we can divide the problem so that it is easier for us to solve it. In this case, we can use site number as the stage of this problem. So we say site T. What about our decision? What are we trying to determine in these problems? We are trying to determine how much money to invest in each site. So decision is how much money to invest. Call it XT. And last but not least, we need to determine our state. As we said earlier, the state is the information you need to know in order to make a decision. What do I need to know in these cases? I need to know, in order for me to invest a particular amount of money, I need to know how much money I already have in my pocket. Again, always remember that state is the information you need to know to make a decision. So it is the amount or the available money. We call it an I. The last thing we need to determine is our objective function. In this case, the objective function is FTXT equals to maximum revenue. Okay, always we go to solve these problems backwards. We start with stage number 3, which we called site number 3. Here we will consider these. Stage number 3. You need to consider all the possibilities. Now, what is a possibility? It is the amount of money, how much money you have. You need to consider all of these possibilities in your states. So I can go to stage 3 with $0. If I go to stage 3 with $0, then from the table, I know that I will get in return $3 or like $3 million. If I have $1 million available, I will invest it in side 3 and I will get $7 million in return. If I have $2 million, then I will invest it and I will get $8 million in return. If I have $3 million, I will invest it and I will get $13 million in return. In the end, if I have $4 million available, then I will invest it all and will get in return $15 million. We need to write next to it our decisions. So x3 0 will be invest 0 because you don't have more money. x3 1 will be invest $1 million or $1. x3 2 will be invest 2. Oops, sorry about that. x3 3 will be invest 3, and x4 4 will be invest all 4 of it. Remember, in this stage, this is the end of the problem. You are supposing that this is the amount of money you have. Whatever you have it, you will invest. Now we will see the difference in stage number 2. Now we are stage 2, which means that I am in side 2. But now I need to consider stage 3 in the future as well. So let's say I have $0 million available. In this case, then, do I have any money to invest? No, I mean, I can't invest any money. So I will invest 0 in stage 2, in side 2. So that's 0 in side 2. And how much will I have for stage 3? I will have again 0. 0 in side 3. In this case, if I invest 0 in stage 2, I will get 3. And if I invest 0 in stage 3, I will get $3 million in return. So we have 3 plus 3, that's $6 million. If I have $1 million available, then I have some possibilities. I need to choose a maximum. What are my possibilities? I can invest 0 or I can invest 1. If I invest 0 in side 2, then I will have 1 for side 3. In this case, we have, so again, we have 0 for side 2, but I have $1 available for side 3. So we have 3 plus 7. So that's 3 plus, I go to next stage with F3 1, or I can invest $1 here. If I invest $1 here, then I will get $6 in return, and then I will have 0. Sorry about that. We'll have 6, but I will go to the next stage with 0. In this case, F31 is 7. So 3 plus 7. And F30 is 3. I have 10 plus 9, choose the maximum. We say invest that dollar in the third stage. Do not invest it now. Another possibility is that I go to stage 2 with $2. In this case, then I can invest $0 in this stage, 1 or 2. If I invest $0 now, I will get $3 in return, but I will go to the next stage with $2 available. If I invest $1 now, I will get 6 in return, and I will go to the next stage with 1. And if I invest $2 here, then I'll get $10 in return, and I'll go to the next stage with 0. So bear in mind one more thing. Here, I have $2, right? We are supposing that in my pocket I have $2. Then, due to this, we are doing this maneuvering of the possibilities. 3, 6, 10. So F32 is 8. F31 is 7, and F30 is 3. We have 11, 13, and we have 13. You can choose either one of them. Whichever solution is good for you. Another possibility is that I can go to this stage with $3. If I come here with $3, then I have various possibilities. I can invest 0, and by investing 0, I'll get $3 in return, and I'll go to next stage with $3. I can invest 1, and by investing 1, I get 6 in return, and go to the next stage with 2. If I invest $2, then I'll get 10 in return, and go to the next stage with 1. And if I invest $3, I get 12 in return, and I go to next stage with $0. So we have 3, 6, 10, and 12. F3 is 13. So this is 13. This was 8, 7, and 3. 16, 14, 17, 15. Now, which was the maximum again? What is our maximum? Our maximum is select, invest $2 now, and leave $1 for the future. Another possibility we have is that we can go to stage 2 with $4. Then in this case, I can have these possibilities. The first one is that I spent $0 here and leave the rest for the third stage, or I can spend $1 here and leave next stage, or I can spend $2 here, invest $2 here, and go to the next one with 2. Invest $3 here and go to the next one with 1, and invest $4 here and go to the next one with 0. So we have 3, 6, 10, 12, 14. F34 is 15. This is 13, 8, 7, 3. 18, 19, that's 18. We have 19 and 17. Which was the maximum? We have two maximums in here. So either invest 1 now and leave 3 for next stage, or invest 3 now and leave 1 for the next stage. And we go to our last option. As we said earlier, Now we are here. So in this scenario, we need to consider only the amount of money I know I have in the beginning. How much money I have in the beginning? I have $4 million. So in this case, because I have $4 million, I need here to consider only F1, 4. So stage 1, and I go F1, 4. Why? Because as I said, I know I have $4 million in the beginning of the problem. So maximum, again, invest 0, 1, 2, 3, or 4 here. And if I do so, then I can invest 0 here, in which I get $4 in return. I can invest 1, which I get $7 in return, 2, $8 in return, 9 or 11. And I go to the next stage, F2 with 4, F2 with 3, F2 with 2, F2 with 1, and F2 with 0. We have 4, 7, 8, 9, 11, plus, 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 plus. F2, 4 is 19, F2, 4, 19, F2, 3, F2, 3 is 17, we have 17, 13, 10, 6, 17, 13, 10, and 6. This is 23, 24. Here we have, I'll write it here. So we have 25, 19, and 17. In this case, we choose the maximum. And what is our maximum? Our maximum is 25. Here, 24, sorry. I have here 24. Wait, this is a mistake I made somewhere. No. 8, this is 21. So we choose 24, that is invest 1 now. So we're investing $1 million here. Then we go to F33. F33, we invest $2 million. So we go to F31. So we invest 2 here. And we invest the one that is left here. So site 1, site 2, site 3. Again, if you have $4 million and you have 3 different sites to invest in, then decide to invest the first dollar in site 1, decide to invest $2 in site 2, and $1 in site 3. Again, there might be mistakes in my calculation, but the logic is fine. Try to understand how we're solving these problems, and hopefully it shall be fine.